Hi everyone. In today's challenge, we are going to solve this problem. The problem name is implement stack using Q, and the problem number is 225. Alright guys, so first of all, what we are going to do? First of all, we are going to clearly understand the problem statement. After understanding the problem statement, then we will move to the logic part. And in the logic part, we are going to see how we can solve this problem. What are the logic and algorithm we are going to use to solve this problem? So everything we will discuss in the logic part. And after understanding the logic part, then we will move to the implementation part. In the implementation part, we are going to implement our logic in Python, C++, Java, and JavaScript programming language. Fine, guys. And guys, if you want to have a look on the solution, which I'm going to write in this video for Python, C++, Java, and JavaScript programming language, I will share one link in the description. You can go through that particular link. You can find all the solution over there. Right. Fine. Now let's see what this problem says. So let's understand the problem statement. All right. So guys, problem says implement a last in first out LIFO stack using only two keys. Simple thing, guys. What they have told us, we have to implement what? Implement a stack. Right? Stack is nothing but a LIFO, right? LIFO means last in, first out. Whatever the element inserted at last will gonna fetch at first, right? Simple thing. The implemented stack should support all the function of a normal stack: push, top, pop, empty. Right? If you know what a stack data structures, so stack data structures have few functions. Inbuilt function like we can say push, which help us to push any data at the end, at the top we can say, and then top, then pop, then empty tell us that whether the stack, whatever stack, it is empty or no. Pop is nothing but used to remove an element. Top is nothing but to tell us whether what is the top element and what is that element value, right? Simple. So push to insert an element, top just to give a top element, not any removing, not any insertion, just to give us the top element, whatever the value of the top element. Pop, remove the element from the top, and I'll tell you what is the order here, and empty just to tell us whether stack is empty or not, right? So LIFO means, let's take a simple array. Let's say this is an array, right? Initially there is nothing, so we have inserted 2. Fine. So after that, what we are going to do, we are going to insert 4. So this push function will insert here at after this. Then push 6, so it's going to push 6 here, right? Then what we are going to say, we are going to say top. So top means nothing but the top element for this is nothing but this one, right? 6. So it's going to give us a 6. Then pop. Pop is going to remove the latest. Latest. What I'm going to say, this is the latest we have pushed, right? So we are going to pop this particular element. So it's going to be not here now. Empty is going to tell us that whether this particular stack is empty or not. So no, it is not empty because it has only 2 elements, right? If we pop one more time, so it's going to remove 4. If we use pop function again, so it will going to remove 2 as well, right? So this is nothing but simple our stack LIFO, last in first out. So whatever element has entered at the last will gonna come the first, right? And you can see this for function they have explained this in detail. So what push element x to the top of the stack, pop, remove the element on the top of the stack, top, return the element on the top of the stack, boolean empty, return true if the stack is empty, false otherwise. Simple, right? Now let's see some more thing they have told us. Notes: you must be only using standard operation of a queue. See guys, they have told us that we have to implement stack using only two queue, right? We have to implement our stack using only two queue, right? And they also tell us that you must use only standard operation of a queue. It's not like when we are using a queue, then we can use all the function, right? We only can use that function which are already defined in our queue. And what are the function in queue? You already know, right? Push, peak, pop, front, size, empty. These are the we can say the defined function of a queue, right? So we can only use this function to implement our stack. Depending on your language, the queue may not be supported natively. You may simulate a queue using a list of queue, double-ended queue, as long as you only need a queue standard operation. Simple thing, guys. Like in our Python, which we are going to use in this particular programming language, right? In Python, we don't have a queue, right? We have a dequeue, so we are going to use dequeue instead of queue. But we are going to use the same function. We can use peak, pop, push of queue, size, and empty. We will not more than these functions. And same goes for any other programming language. If we could not able to find our queue in that particular programming language, so we are going to use their standard function data structure like list or array list, any other data structure, right? Fine. So this is a simple problem statement. We are given two queue. No, we are not given two queue. We are given we have to implement a stack using a two queue, right? We can create a two queue, right, to implement a stack, but we have to implement a stack. Fine. So let's see the example one. So example one, first of all, they call a constructor my stack. My stack, they call a constructor. Fine. Whatever we have to do, we will do here. Then they have pushed the element one. So let's see here. Let's make a space. Not here. Let's make a space here. So they push a stack one. Fine. We push at that. We are taking considering as stack now, right? We're not going to do a code. We're not going to do a brute force anything. Just we are seeing that how stack is going to work, right? So we have pushed the one, so it should come at the here. Then we have pushed two, two should come here. Then we have to top, use the top. So what element should we come here? Two. You can see in the output as well. We got two, right? And see guys, here I am just telling you in the consideration of stack, right? But in the back end you will not using the stack. You have to use a queue only, but your output should be two only, right? Then they again call a function pop. So if you are going to do a pop, so what it's going to do? It's going to remove this two, but also going to return the value as well. So it's going to return two. Then empty. Is it is empty or not? No, it is not empty. It has at least it has one element, right? So we are going to return false. Simple, right? So constraint, let's see, x is going to be less than or equal to 9. Fine. So what is the x? Which is less than or equal to 5. X is nothing but the value, integer value, which we are going to push in our stack. At most 100 call will be made to push pop, top, and empty. So at most 100 function they can call with your object. All the calls to pop and top are valid. So we don't need to make a check anywhere by using pop and top, because we know they are going to be valid, means there are going to be at least one data present in our pop and top, right? It's fine. Now important thing, follow can implement the stack using only one queue. See guys, in the problem statement they have told that we have to implement a stack using only two queue, right? So that's cool. Everyone can implement this with two queue, right? So just we need to take one queue for insertion. Whenever we need to pop, we can take a help of second queue and we can do this part, right? But now if you focus here at that, they told us can you implement the stack using only one queue. So in this problem, that only we are going to do. We are going to implement our stack using only one queue, right? I hope it makes sense. So how we are going to do this? First of all, let's see the logic part, right? Without logic, we can't move to the implementation. Fine. So in logic, what we are going to do? We are going to say, okay, so we are taking the example of anything, right? So let's say I'm saying that some numbers 1, 2, 3, 4, 5, 6. These are the number we have to push, right? So first of all, we are going to take a queue, right? So let's first of all solve first example, then we'll move to this. Otherwise, it will be going to be very complex. So in the first example, we have to push one, right? So as you know, we are not using a stack. We are using a queue, only one queue. So let's give it a name queue, which is going to be one queue, right? So what I'm going to say, I'm going to say find this queue. Remember, this queue not a stack, right? Fine. So I have to push one. So in queue, what we can do? In queue, let me tell you first of all, in queue, what is happen? Queue is nothing but you can say FIFO, first in first out. What are the element enter the first, that will only come at the first, right? In the case of stack, this was leaf last in first out, right? So how does it work? Let me first of all show you. So let's say this is queue, right? So we enter one, then we push two. Then if we want to remove any pop element, we want to use a pop function, then what it will do? If it was a stack, so it has to remove the latest element which we have insert two. But in the case of queue, it's going to remove the first element, which is one. And this is going to be look like now this, right? Now again, if we are going to insert 3, it's going to insert at the end, right? 3 is going to insert at the end, 4 is going to insert here. If you want to again pop, so it will remove 2, right? If you want to get a peak now, the front top element, in the case of stack we use top, in the case of queue we use a peak function. Peak function return the front element which is going to be pop in the next call, right? So peak here is nothing but peak is nothing but 3 only, right? So it's going to give us 3. In the case of stack, if we use top, so it has to return 4, right? Simple. This is the basic difference of stack and queue. In the stack we have a last in first out. In the queue we have first in first out. In the stack we start popping whatever the end element which we have insert the latest, but in the queue we insert the first element which we have inserted in our data structures, right? And in queue we have peak, in the stack we have top. Simple, right? Now in the example one, we have to push one. So what we can do in the queue, we can say push one, so it's gonna push here. It is empty, right? So it's gonna push here. Then it's saying that push two. So where it's gonna push here too. Fine. So in the case of now, if we are gonna say just give me a top, but in the stack we don't have top, right? So what we're gonna do? We're gonna say okay, just return a peak. So if we're gonna say peak, so it's gonna return this one, but we don't want this, right? Q will gonna return the that particular element in the case of peak, which is going to be removed if we call up dot push pop function, right? But what we can do now, we can say fine if it is the case. So now guys, you can see we have to return a peak. We don't have to return. We have to return top, right? Miss top of the stack. So we don't have to pop anything, right? So whenever we were inserting, so again let's do this thing. So whenever we are inserting, we have to make one global variable peak, right? See, I'm changing the color. Peak is my now global variable, right? Or you can say any variable name. Initially it's -1, right? So whenever I have to insert something, so as you know in the example, let me just move this code. So in the example, we have to push one, right? So whenever I'm pushing something, let's say I push one, right? So what I'm gonna say fine. If I push something, so I'm gonna update my peak. I'm gonna say peak is now one. Okay, then I have to push two. So push here and peak update, peak is two. So every time you're gonna perform a push function, you have to update your peak. Now if they ask photo, right? They're asking a photo, that means you have to return the top of the element of a stack. So if we consider this stack, so this is going to be 2, right? And you can see peak is storing our top of the element. So we can have return peak. So I hope you understood. This is just big of one operation now. Big of one operation to get it top using a queue. Right? I mean big of one operation to insert in a stack to push, right? Now let's see the pop, right? Next function is nothing but pop only, right? Pop. So that means nothing but we have to pop in the queue. If we use a pop method, so what it's going to remove? It's going to remove this one, right? Because this is the peak element, right? So if, but we have to consider queue, right? Or stack, right? So in the case of stack, this should be removed because it has come at the latest. So let's see what time complexity we are going to get for pop. So what we can do now, guys, for pop, we can't perform in big of one. Why? Because if we remove this element somehow, we have to reach from this to this one, right? So this is going to cost big of one, big of n, right? And we have to reorder again. So what we can do, we can say all right. So whatever the element starting from this till this one, just keep inserting at the end. Let me give a case here, guys. Let's say there are some element 2, 5, 7, 8, and this is 10. So I am saying here that, guys, let me make it bigger more. So as we have to say pop, right? So pop is going to remove this one in the case of stack, right? So in queue, what we can do, if we in queue we use pop, then it's going to remove this two. Don't worry, we're going to do this only. First of all, we will find the length of this queue. So this length is 2, 4, and 5, 5 length. So we are going to perform 4 times 5 minus 1 means length minus 1 4 times. So we're going to pop, so we're going to pop 2, and we're going to set at the in this we can say we are going to push in this queue only, right? Fine. Then we are going to pop 5, we are going to push here only. We are going to pop 7, we are going to push here only. We are going to pop, let me just make it undo. Why? Because I want to show you that it has not changed earlier as well, right? So what I'm going to do, I'm going to say fine. So push, we can say pop this one too and push it here. This is nothing but at the top of this, right? This is nothing but this at the top of this, right? So let me just give it here only, but we will see this case as well, right? 2, then push 5, then pop this 7 and push here in this stack only, queue only. Pop 8 and push here. Now 4 time 4 call has already been made, right? Because we have to do n minus 1, length minus 1. Fine. Now the last one, we are going to not we are going to pop, by the way, we have pop it and we have written this one, but we are not going to push it. So if you will focus now, so this is nothing but our stack, right? We have pop the top of the stack by using a queue only, right? And maintain the order as well, right? I hope it making a sense. So this is the only we are going to do in this case as well. So we have to pop. So we have to pop means we have to remove 2. So first of all, we are going to we can say pop this one. We're going to push it here, and then we are going to pop this 2. But this is the element which we have to pop. So we are going to pop this. We have to return 2, but we are not going to push, right? So now my stack, new stack, or we can say queue, is going to look like this, and this is fine. Fine. Right. Now what we are going to do, we are going to say the last method is empty, right? So where it is going? Yeah, here. The empty, just we can use simply method of queue only. If there is at least one element present in queue, that means it is not empty. So you can see there is one present in our queue, so we are going to say it is not empty. It is false. Simple. I hope you understood this particular case. If you did not understood the big of this form, which is taking big of n cost, then don't worry, guys. In the implementation part, you can easily understand this particular logic. But for now, just keep in mind we're popping all the element which are below to this to reach this particular top of the element. We are popping all the element and reinserting in our queue only, right? And that's how we are getting our top of the element, and we are removing that element as well, right? Now let's move to the implementation part and let's see how we can implement this. All right, so here, guys, first of all, I'm in the Python and we have to use one queue only, right? So what I'm going to say, I'm going to say self dot collections, and this is going to be tq. As in Python we don't have q, right? But in C++ JavaScript we are going to have, or Java we are going to see how we can do this, right? So let's say I maintain a one dq and also one q, not one q, one p. So peak is minus one, right? Initially minus one. I'm going to say fine. So what I can do, I can say 4, not 4. In case of push, what we can do, we can say before pushing, just maintain your peak as well. So update your peak. Peak is going to be now x, not semicolon here, and then you can simply say, I haven't given name. All right. So this is not going to be self.q, right? I don't know what I have done. Fine. So collection.tq, right? I don't know where's my mind is going. Right. Fine. Self.q is collection.q. Self.peak is minus one. Now what we are going to do, we are going to say before pushing anything in our stack or queue. So what we are going to say, we are going to say just update your peak first of all. Then you can say self.q dot append this particular x, right? Once this is done, then what we are going to do, we are going to simply find. So in case of pop, there we have to use some big of n post of operation. So for that we can say find, first of all find a length, which is going to be n is length of self.q, fine, and then we can use a for, we can for a range of what I can use, I can say n minus 1, right? So remember, then we are going to say okay, self.q, you have to append, what you have to append, you have to append self.q dot o left. So it's going to remove the uh, left element, first left element, and then you're going to insert at that, right? So we have to perform this n minus 1 time. After doing this, and but we can't do this as well, right? So for doing this we have to update peak as well, right? Every time, then only we can confirm this one. So self.peak is going to update with we can say self.q dot pop left, fine, and now we can self.q dot append self.peak. Now this is, by this doing, after this doing, we can maintain our peak as well. Once this is done, at the end we are going to say okay, the last element we have to pop, no doubt, but we don't have to push anyway, right? So we can say return self.q dot pop left. So what this is going to do, this is going to remove the left element and also going to return. So this left element, first left element is going to be nothing but the top of the stack, right? So this is how we have maintained the pop as well. Now how we can do the top? Simple, return self.p, fine, and empty we can simply say self dot what we can do, we can simply say return length of self dot q dot q is equal to 0. If it is equal to 0, it is empty, otherwise it is not empty, right? Now let's see whether that's working fine or not. So let's run this code. I hope it should work, right? Let's see. And you can see guys, the test case is getting passed, so let's try to submit this code. And it also got submitted, right? So you can see we have done with the Python. Now let's move to the Java, not Java, before that C++. In the C++, what we are going to do, we are going to simply say first of all define two things. First of all q in, and we can say q, then in p, fine. After doing all these things, then we can say in case of push, we have to maintain our peak. So we can say peak is going to be nothing but x, and q dot push, you have to push your x, right? Fine. Now what we can say, in case of pop, first we have to find length, which is going to be q dot size. Then we can say for int I 0, I less than n minus 1, and minus 1 operation we have to perform, where we are going to say our peak is going to be update, peak is going to be q dot peak dot p, we can say q dot, what we can use peak only, right? And because it is a queue, so peak is going to return the front element. Once we have updated peak, now we can say q dot pop, now q dot push peak, fine. At the end, after this n minus 1 operation, the last what we are going to do, we are going to say fine. So our result is going to be nothing but peak, q dot peak, and at the end you can say q dot pop, then you can simply return your result. So this is going to return the top of the stack. Simple. After doing all these things, in the case of top, we can simply return peak. In the case of empty, we can simply say return q dot is no, is only empty, right? Fine. Now let's see whether that's working fine or not. Simple guys. The basic, I think it's a easy level problem, right? But we got an issue in this as well. So there's no member named peak. Why it is no member peak? So q dot peak, right? We can use a front if it is not there, and here as well front we have to use, right? Now let's see. Alright, you can see guys, all the test case passed. So let's try to submit this code. So let's see whether it's getting submitted or not. And you can see guys, it also got successfully submitted. Now let's move to the Java. In the Java, what we are going to do? In the Java, first of all, we can say, okay, let's define two things. First of all, Q, integer, Q is going to be simple Q. Then we can say P, which initial -1, set -1. Then we can say Q is going to be -1 new, link, late. Fine. Now in the case of push, what we are going to say, first of all, update your P is going to be now X, and Q dot add this X, right? In the case of pop, what you're going to do, you're going to say first of all find a length in n is equal to q dot size, or int I is equal to 0, not int I is equal to 0. What I'm doing, all right, so okay, n minus 1 I plus plus, right? So we are using a loop now for n minus 1 operation, right? Then what we are going to do, we are going to say take for front element of q. So int not in, we have to put in p is going to be q dot p. Instead of that, we can use a poll, right? What poll will do, it will take the front element as well as remove it, right? So after that, we can say q dot not push, you can say q dot add this p, right? And at the end, we can also say return q dot call. The last element we want to poke and return as well, but don't want to push, right? Don't want to add, right? Fine. And after that, in the case of top, we can simply return our p. And in the case of empty, we can simply say return q dot is empty. Fine. Now let's see whether this will find or not. I hope it should work. Let's see. And you can see guys, it successfully got accepted. Let's try to submit this code, and I hope guys it should also accept it. You can see that it's beat 100% of the user. Fine. Now let's move to the JavaScript, last programming language. So in the case of JavaScript, what we are going to do, we are going to find this dot q empty array, because in this case I don't know whether we have q or not. And after that, what we are going to say, we are going to say find this dot peak is going to be -1. Fine. In the case of push, what we are going to say, we are going to say this dot peak is now going to update with x, and this dot q, you have to push your x, right? Fine. In the case of pop, we are going to first of all find a length, so we can say const n is going to be this dot q dot length. We have to use a loop for let not capital let n is equal to 0, I less than -1, I plus plus. And here, first of all, we are going to say, okay, peak should be updated now, not peak, this dot peak. This dot peak should be updated now with what? With our this dot q dot shift. This dot q dot shift is going to be do nothing but it's going to remove the front element, first left element of q, and also going to return that, and this will store in our peak. And then we can see this dot q dot we can say push. What you are going to push? You're going to push this dot peak. Fine. And then also we can simply say once n minus 1 operation done, we have to remove the last element, right? Last, we can say first element of our q, right? And that also we have to return it, but we don't want to insert it again, so we can say return simply this dot q dot shift. It will gonna remove as well as return it. In the case of top, we can simply return this dot peak. In the case of empty, we can simply say return this dot q dot length should be equal to 0. Let's see now if it is working or not. And you can see test case is updated, so let's try to submit this code, and I believe it was also gonna. And you can see guys, it also got accepted. So we have done quickly with the implementation with the Python, C++, Java, and JavaScript programming language. I hope you understood the implementation part. If you have any kind of doubt in the problem understanding part, logic part, implementation part, you can write directly in the comment section. I'm always there to help you. And if you have understood at least one thing in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.